All right, guys, so welcome back to day two of our session, and I apologize for a slightly slow start. What we are going to do today are two things. We are going to talk about what does a true enterprise scale RAG implementation look like. Are we together? And we are not going to build it. Of course, we won't get time, unfortunately, to build that, but we'll get time to get started with the RAG to Riches project, walk through it, use it, and I'll make sure that you all have owned that code so that you can evolve that code to do some of the stuff that we are talking about today. I will be here till very late at night. So when we go to the hands-on part, do not worry. If you get stuck, I will be there. And also my team will be there. Actually, Samantha, uh, uh, as soon as it is 9 o'clock and their stand-up time is there, remind them that they have to join and help people who come. So, all right, so the team will be there and they'll all help you make sure that you are able to get started with that project. Is that fair enough, guys? So let's start with what we did last time. Last time we said that a RAG pipeline constitutes two things. It constitutes a retriever system, which is mostly and from there, the top tier results go into the generator system or module, and you get a response, you get a request. Right? This is your basic picture of RAG, isn't it? There is a term that we use these days for it. We call it baseline. It is baseline RAG. We saw this baseline RAG in action last time. Do we recall what was the limitation of this baseline RAG? We tried that experiment. We gave it a book on a Greek civilization, ancient Greek civilization. When you ask it a question on ancient Greek civilization, hopefully it gave it to you from the document. Do we recall that, guys? Yesterday, day before? But what happened if you asked it a question for which you had not given it data? We asked it about Indian civilization and the Chinese civilization. And even though we had not given it facts, it nevertheless produced an answer. Right? And the reason for that happens to be the fact that an LLM, it has principally two characteristics. One is it has the ability of language understanding. Right? It's a language understanding model, and it's marvelous at it. And then it also has parametric memory. Because it has read all the world's literature and all the technical documents and everything, it turns out that it remembers all of that. So you can ask it a question and it will answer you for that question. Now, it could be for good or for evil. Sometimes you want that. You want it to answer you, and then you augment that which it doesn't know with your document, with the retriever system. That is one perspective, isn't it? So, for example, you like the fluency of ChatGPT, let's say a GPT 4.0 model or something like that. You can access it with an API, but GPT 4.0 or GPT whatever, or Anthropic or Cloud or Gemini or your DeepSeek or your any one of these Qwen, they are not aware of specific corporate proprietary documents, right? The knowledge base that is within your company. Right? But you would like the same fluency of answers, natural language conversation, to be propagated not from just public documents to also your corporate corpus, corporate knowledge base. So the way to do that is this RAG pipeline. In such a situation, you may not mind that if you ask it a question whose answer is not there in your corporate documents, the machine answers it anyway. The LLM answers it anyway from its parametric memory, isn't it? On the other hand, sometimes you want it to not answer from its parametric manner. You want it to only answer the question from the documents. You want to say knowledge should come exclusively from the retriever system, and language understanding is all that you want to use of a large language model, right? And for heaven's sake, let it have some dementia, right? Let it not remember all that it has learned. But language understanding is what we want in that particular model, right? So how do we, why are situations like this? One example that I gave, which happened, by the way, to a large semiconductor company in the Valley, let it not be named, they applied RAG to a RAG pipeline to their documents to help customers. So all the customer support documents were there, product marketing, product documents were there. And the customer, one user was saying, oh, this doesn't work. And is there a way to fix it? Or is there a better way? Do you have a product that addresses a need? And the chat bot had said, no, unfortunately, we don't have it, but may I recommend you this other products? And it listed out the products of the competitors, right? So that might be very helpful to the end user, but not at all something that the enterprises would like it to do. Because you don't want your chatbot to be the marketing agency taking traffic to your competitor. Right? So that is when you don't want the parametric manner. So when you do the baseline RAG, you don't get such safeguards. So what we will do is we will take that as a use case, because most of the time when you apply RAG, you will be applying it to a real use case in your enterprise. Right? Now, let me give you an idea of the state of the art. As I mentioned before, today, if you want to look at the state of the art RAG, agentic RAG implementations, the ChatGPT itself is that. It treats the web as the search index, and it has also indexed a lot. Perplexity is an agentic RAG system. Gemini 2 is an agentic RAG system. These are flagship RAG implementations. They started out as just chatbot on top of an LLM. That was 2 years ago. But today, they are full-blown agentic RAG systems. And they're exceptionally well done. So one of the paradoxes that people face is, for example, OpenAI will tell you that, see, whatever model we use, we have made it available to you at a token cost, right? You pay for the tokens and you can access it over the API, OpenAI API, right? And all of us have OpenAI API key. But how many of you would resonate with the following observation? When you use the LLM model and you invoke it from your code, you get back a response. The quality of the answers that you get is not as good as what you get from ChatGPT. If you resonate with that, please raise your hand. Right? So what is the difference? ChatGPT is being honest. OpenAI is being honest. They're saying, yes, behind a ChatGPT, let's say GPT-5, is exactly the same model that we have opened out to you. So wherein is the difference? The difference is that they have done a world-class, absolutely stellar agentic RAG implementation. And what companies do internally is, and if you remember, we ended the last session with a statement that agentic RAG in general, is deceptively simple. How hard can it be? Like you remember, last week we did it in 5-6 lines of code. Looks simple. Now we can immediately go update our LinkedIn resumes, RAG experts. Right? But it doesn't work like that. RAG is deceptively simple, but extraordinarily complicated to do to perfection, to do anything comparable to Perplexity or ChatGPT. See, you don't have to have the scale of Perplexity. Those are web scale. They take web scale traffic. You may not have that scale because you're working with a more limited data and a more limited client base, just one company, internet, or a customer base of a company. Nevertheless, nothing says that you should not achieve the same quality and usefulness and precision that Perplexity or ChatGPT achieve. Would you agree with that, isn't it? You would like to see that. And the main thesis that I make is it's actually doable, but there are many subtleties. There are many rabbit holes that you have to take care of. So in the first hour, and I won't take more than an hour, less than an hour actually, 40 minutes, maybe 30 minutes, I would like to take you down some of those rabbit holes. Right? So in a rack system, there is, so let's look at this and start at the one end, the right end. What could go wrong with a user request?
Vague.
Yeah, vague requests. What else?
May not have context.
May not have context. Yes. What else?
Garbage character.
Garbage characters. Was that
Incomplete.
incomplete? And so on and so forth.
And dangerous content.
What's that?
Asking for dangerous content or
Asking for
content.
dangerous content,
Yeah.
toxic requests, many such things, right? And by the way, without naming companies, there are a lot of studies. I mean, they're embarrassing cases. A very stellar company, a company with stellar engineering and PhDs, armies of PhDs, embarrassingly, a web scale company added something like this to their application. And if you happen to know that, you know which one I'm talking about, but it's one of the top tier ones. And there was this a very embarrassing situation. Underage girl went to that and asked that I've been asked by a more mature male for a date. What should I do? So that's a system with good guardrails would have immediately said, don't go. Right? You should instead what it suggested is how to take good candles to create a more romantic and how to dress to create a more romantic atmosphere. You can imagine how dangerous a response like that can be. Right? So we all learn. See, we are all, even big companies, we are the frontiers. Things are changing very fast, and we are learning by making mistakes. Yes.
Just today there was a case of somebody, ChatGPT assisted suicide.
Are you serious?
Yes. So the parents have sued OpenAI
My
for
goodness.
that ChatGPT kept on giving the underage boy advice of how to commit suicide.
That's hard. My goodness. See, ChatGPT has gone through extraordinary amount of safety training and guardrails. I'm surprised that this case slipped through. In fact, that itself will become a research case study. How
Today
exactly?
today they filed a lawsuit.
Maybe it happened 6 months back.
Just
No,
news was
the incident. When did the boy die?
maybe.
Oh,
Because I mean,
Yeah.
guardrails it really didn't exist even 6 months back.
so yeah, it's a fast evolving field. Even I mean, if stellar guys like OpenAI are making mistakes like that, you should get an idea of it. So anyway, I'll give you. I'll rush through this a little bit. See, user request is the weakest link in a RAG pipeline. People forget it. If you ask people which is the weakest link, they'll say maybe my search system isn't good. Maybe I need a bigger LLM. Right? Invariably, people think, okay, let me go get a bigger LLM, bigger brain. Paradoxically, if experience teaches us something, I'll tell you what my experience has taught. Beyond 70 billion parameters or so model, which you can easily host in a fairly modest workstation, you reach, I would even say around 30 billion, but 70 billion, let's be that. You reach a point of diminishing returns. You don't really get much by getting a bigger brain into your RAG pipeline. In fact, all you do is rake up bigger bills, right? And increase latency in compute. So that is not the answer. If you want to improve your RAG system, build a mature pipeline. And so pipeline is a message I'll take you through. And let me take you through that message first. So user request, first thing is that, so I will just, so because I help a lot of companies, startups and companies who are doing implementations, I'll tell you what are some of the things that I found. Right? So because, and these are the things that you learn from experience, like you don't find in Medium articles or something, because it's so direct. People don't mention it. The moment you release anything, even within the intranet, guess what's the first thing people will do? They will just do keyword smashes and hit. If you let that query go through, do you realize that it goes through your entire retriever system, your entire LLM? It's a wasted compute, isn't it? How long does it take to detect that you're looking at gibberish? No, you need a guardrail that instantly knows it's a gibberish. Those guardrails are extraordinarily cheap, inexpensive. In fact, some of those are not even machine learning, right? They are actually dictionaries, the databases of keyboard smashes. You're just doing a lookup in a map. Then there are old statistical tests. Are we looking at gibberish, out of vocabulary words, and so on and so forth? Ratio of out of vocabulary words, entropy tests, extraordinarily inexpensive that you can do to know. With these detectors, all of which function in sub-millisecond on good hardware, you can eliminate gibberish. There's a surprising amount of gibberish that comes. Sometimes it's people just fooling around, just saying, what does it work? And lazily hitting keyword smashes. Sometimes it is just accidental. They're not paying attention and they're on their cell phone, words are being typed and getting entered, right? So you want gibberish. Then the other more important thing is, see, if you have a RAG pipeline. So here's the thing. We had a client. The RAG pipeline was for a particular domain, right? It was actually for health and wellness, a specific topic, and for a specific class of people, right? Demographic, meant for that demographic. Now, do you think that a question, can you tell me how long will it take me to go to the nearest galaxy? A legit question? It's irrelevant, isn't it? So, what should you do? You need to have a relevancy detector, isn't it?
Yes.
You need to know a classifier exactly. And people tend to forget that just because they are LLMs doesn't mean that the rest of computers, the rest of machine learning is now in its grave. Right? It is very useful, it's there. And how much does what is the inference time from a classifier that can do relevance detection and fine tune to do relevance detection in a pipeline? Sub-millisecond. These are just you can train a modern bird with just 10-12 minutes of fine tuning on a reasonable data set to make it domain specific. So if you get a query out of domain, you just politely say, well, we would rather that you focused on topics in domain, right, on health and wellness. It saves you a tremendous amount of compute. Are we together? The third is toxic. You need to know, for example, some things simply don't have a good answer. Politics and religion are two good topics. Right? There are no right answers. Every answer is wrong and will offend somebody. Isn't it? Right? The moment you need to absolutely stay off topic. So a relevance detector will automatically weed it out, isn't it? It will say, well, not relevant to health and wellness. Right? Then you can have toxicity detection. Like, for example, sometimes the user, you can sense toxicity in the language, hate speech in the language. That also, sub-millisecond, you can detect. Those detectors are extraordinarily effective, very effective, because toxicity in text detection has been evolving for a decade now. And those toxicity detectors are extraordinarily mature. You can quickly weed out those requests. So what are you doing? You're putting gates, right? There is a place, I believe, either in Italy or in China, in which you have to go through 100 gates. Where is it? Can somebody tell me? You go to a location, but you go through 100 gates or something like that, right? I always think of RAG systems like that your query has to journey through 100 gates, right? These are your gates. You look for toxicity and you weed it out. But then comes another interesting thing. Have you heard the saying, there's nothing new under the sun? Right? How can that be applied to user query? See, what happens is, if you build, and as you will see when we talk, a good RAG system has many complicated parts, which means that the actual query that makes its way fully through the RAG, you allocate a significant compute budget to it, right? You go overboard in giving a perfect answer, and you never do it in one pass. What you do is you take the answer, then you say, can I make this answer better? Can I go back to the documents, go back to the sources and find more things and do that and then make the answer better? And you iterate a few times till you have the perfect answer. So you allocate a significant compute budget to come up with the answer. You can see that how many of you are using GPT Pro? You see that anytime you ask it a question, and if you look at the details, and DeepSeek and all of these, they're doing that, right? The agentic system is searching the web, finding things, reasoning, putting it together, going back and searching for some more, then saying, oh, no, maybe I'm not quite right. Let me look into this. Building towards an answer. What is the compute budget that goes for it? You can imagine that it is significant. That's why they're charging you $200 a month, right? I, by the way, frankly feel that it's a huge bargain because the compute budget they allocate to anything like that is so much that if you are a frequent user of that morning to evening like I am, it's a steal, right? So if a good RAG system should be doing that, but now look into an enterprise RAG system that you have built. Think about it this way. Here is the data. We repeat ourselves 30% of the time, which means 30% of our own queries are semantic repeats. Means we are asking essentially the same question with different words. We forgot that we asked, or we are too lazy to scroll back and remember the answer we got. Right? How many of us are guilty of doing that? We all do that, right? So 30% of the time you repeat yourself. Then within an intranet, within a corporate enterprise environment, if you have a question, quite likely your colleagues have had that question, isn't it? The repetition rate is in the 90s, sometimes in the high 90s. But there is one problem with that, which is that human beings, each of us have our own diction, our own way of expressing. If I gave you something to say in your own words, each of you would ask the question somewhat differently, especially if it is a little bit more complicated. It's not something as simple as, is it a Wednesday or Thursday? It's a little bit more complicated than that. You will articulate it differently. That's what makes it's the flexibility and the beauty of the natural language. So what do you need to do? You can't use a cache, basic cache like Redis or something like that, because they would look for exact keyword match to the answer. What you need to do is something interesting. Every time you serve a query, you get an answer which you have done after a lot of compute. Common sense says that that which is computationally resource intensive to produce, you should cache. You put it in a cache, except that in the cache, there's one catch. The user may be asking the same question with a different word. You can't do a keyword lookup. So what you need is a semantic cache. Semantic cache, right? Semantic cache means you say, has a question been asked which in its semantic intent is the same as the user's question, right? And would you agree, especially in enterprise environments where 90% of the query, more than 90% of the queries are repeats, that you shouldn't build a RAG system unless you have a semantic cache? Common sense, guys, isn't it? Right? Because then, if 90% of the queries, let's say, are repeats, or actually sometimes it's 99% of the queries are repeats, what happens? It means that suppose you have a hardware and you maintain a semantic cache that actually works, you will have 1/10 the load on the hardware, isn't it? Or put another way, your OPEX budget will be 1/10. Operational expense budget will be 1/10. Computer hardware need will be. Actually, it's more like between 1/10 and 100, right? Because the The semantic hits are very high actually in enterprise environment. Now the whole question is, how do you do semantic cache? That's a topic for a different thing, but the fact is it can be done and it should be done, because if you don't have a semantic cache in your RAG pipeline, you know what you have ended up with? A cashless cow. And you don't want a cashless cow, right? Does it make sense, guys? So that is it. Now your query moves forward. Here comes a question. Human language is filled with typos, right? Sometimes we say, we mean the opposite of what we write. Sometimes you forget the word not. But the previous context will lead you to, if you read it, you know that the user forgot the not. The meaning is the opposite of what the user meant. We do that, isn't it? And people write atrocious English. Have you tried it with things like GPT, Gemini, Anthropic, Perplexity? They are extraordinarily good at figuring out what you're trying to say, isn't it? Why is that? It's not just that. It is called query normalization. You always assume that what the user has given is filled with typos, filled with omissions, right? And has perhaps contradicted itself. It departs from what the user really meant. So you need to rewrite the query based on what the user meant. Right? So this is the topic of, and this comes under the broader topic of, now we are touching upon a topic. By the way, are you guys having fun with all of this? I'm giving you what a real RAG system requires. It is called query transformation. So the first thing is query normalization, where you fix the grammar, you fix the diction, you elaborate it. But sometimes it's more specific. I was working on a project for a logistics company, right, which was an aggregator across many shipping things. One of the user queries that was common was, right, where's my stuff? And here was a tracking ID. Right? Now, what happens is that, what can you do with that? What you had to do is we took that ID, what was there, we had a regex, very simple. See guys, you have to remember that because we're in the world of LLM doesn't mean that LLM is the only thing we have to use to solve every problem. Sometimes holy old computer science still comes in useful. You just use a regular expression. Right? If you have a regex match, because FedEx has a regular expression package for its packages, regex matching, UPS, each of the DHL, etc., USPS, their tracking numbers have a particular pattern which you can convert into a regular expression. You maintain a library of regular expression. The moment it matches in the query, what can you do? You can do query transformation. You can say right there, where is my stuff? It is a parcel. So for example, the pattern will also tell you that it's an air parcel or air package, or it is a ground package, or what it is, right? It is a UPS ground package with the tracking ID blah. Do you realize what we just did? We contextualized the query in a meaningful way, because when it goes to the pipeline now, in the retriever system, one of the retrievers would be the query into the database itself. This query as text can be more easily converted into SQL on the fly by a LLM. And therefore, you can look up a SQL database if the answer is there with you, or immediately it can be understood that this using a tool that will do an API call to a shipper to know the latest status of the package. Does that make sense, guys?
Yes.
Right? So that is an illustration, practical illustration of query transformation and query normalization. Right? So, guys, as you think through the RAG pipeline, you will realize that now you're getting some color into what I just said, that RAG is deceptively simple till you realize it is not. There are many rabbit holes that you have to go through. But another rabbit hole that we go through in this space is, so I'll illustrate it with this following situation. See, guys, when we human beings have what is called the theory of the mind, which means that when I'm talking to you, then I have an understanding of who you are, your technical audience, you have this, that. So I could use the word drag without at all fearing that you're thinking of torn clothes, isn't it? Rag is very specific, it's contextualized, its meaning is contextualized. It comes from my theory of humor, isn't it? Who you are. When we converse, human communication is fluent, effective, because we carry an understanding of what the other person thinks. Right? On the other hand, now imagine this situation. You enter a store, which is a very busy electronic repair store, right? And imagine that you walk over there, huffing and puffing, and you say, 3 days have gone by. What are you guys up to? What do you think the poor customer service representative will do? Does he have any clue what's being talked about? Right? A good customer service representative would do what? It would say, "Oh, I'm really sorry about that. May I please have your name? What did you drop?" Then look it up. If you can't find, when did you drop your stuff? Do you have a case ID or whatever it is, ticket ID or something like that? Make sense, guys? What is the customer service agent trying to do?
Context.
Yeah, retrieve the context of this query, isn't it? Contextualize the query, isn't it? So contextualization is part of query transformation.
That is domain specific.
Yes, is domain, and also in an enterprise, your department, your role specific.
Yeah.
Isn't it? Right. So that is important. But there is also something that's important: query decomposition. Actually, let me just say query, which is implicit rewrite. I consider it part of query normalization. Whenever you get a user query with all its typos and everything, one of the first things you do is you actually don't pass that text into the system. You instead rewrite that query to be more elaborative, explanatory, and pass that into the system. Are we together? So, for example, our replacing a tracking ID with the full sentence is a tracking ID, etc., is part of contextualization, a part of rewrite. So all of these have overlaps that happen there. But what is query decomposition? It's a very interesting thing, and I suppose I should best illustrate it with an example. Suppose the user says, so this one you'll have to listen to me carefully. So actually, why don't I write it down so we can all stare at it? Let's say that we are talking about, you go to ChatGPT or something, and you say,
So do people like enterprises build the whole system from scratch, like from semantic cache to all of these systems that you're explaining?
actually, let me put it this way. Thank you, Neela, for asking that question. Okay, so maybe this is a good way to segment the question. Did I end last time with a quote from Tolstoy? Something about unhappy families.
Yeah.
Right. So Tolstoy's famous statement at the start of Anna Karenina, the book was, all happy families are alike. Each unhappy family is unhappy in its own unique way. The trouble with RAG implementations is, what I have found is that wherever I go, I find a bad implementation in its own unique way. Right? One unhappy RAG family for its own special reason is really extraordinarily few well-done enterprise implementations. And here's my thing, and I'm being opinionated. I ask your forgiveness for that. See, it comes from not knowing that you don't know. Trouble is, there are all these libraries, Python libraries, etc., and there's YouTube videos and articles. So very soon you can convince yourself that you know RAG. Right? See, what's the evidence of that? You know more RAG than this guy next to you, sitting in the cubicle next to you. So you feel, okay, I know RAG. What you know is a little more RAG than this guy, but it doesn't really mean that you can create a really mature enterprise RAG system. See, behind RAG is more than 1,000 research papers now, 1,000 or more, right? Companies like this, I know what they are doing when they do it right. I'm quite aware of I'm aware of it through the research papers. I'm aware of it through conversations. The Silicon Valley is an echo chamber. You know what everybody else is doing. So the ones who get it right are working extraordinarily hard. Right? And you can see hints of it in public statements when people say, right, oh, behind ChatGPT, behind any one of these, actually our architecture is far bigger than most people think. What is it alluding to? There is a lot more goes into doing something right. All of these things look deceptively simple. Right? And therein is the opportunity. See, if you know all of these things, you know how to build these things right. Guys, you have a moat. Think about it. Perplexity. Imagine the gumption of a young kid getting out, finishing a PhD, and then saying, I'm going to compete with Google. Right? Are you kidding? Right? And yet sits down, builds what is essentially a RAG, isn't it? And nevertheless, if it was that easy, there should have been 1,000 imitators of Perplexity, competitions to it. Why are they not? Because this implementation is hard. And doing it right is an insurmountable moat. In business, you always look for a moat, isn't it? So that competitors can't catch up. In our field, it's always been that. Everybody has ideas. Implementation is the thing, is the moat, right? And that's what I'm giving you a hint of, that what it really involves. Anyway, I hope I answered your question. Dhananjay. Yeah. Okay, go
I
ahead.
have a quick question.
Would you mind turning on your microphone, please? Yeah.
Can you hear me?
Yes.
Yeah, I have a quick question. I think you talked about query normalization, contextualization, then rewrite, and decomposition, right? How do you bring in the trust? How do I know?
We're getting there. We're getting there.
Okay.
Yeah.
Because I experienced a scenario yesterday.
Yeah.
I used Perplexity to look for an AC system, specifically in San Ramon or Dublin, California.
Mhm.
And I asked Perplexity to come back with the best AC system, with a couple of requirements, number of SEER rating, number of tons and all that. When I tried it, I didn't log into Perplexity. I'm still a guest using Perplexity, Elena. I used it on the phone, and then I used it on the laptop. I pretty much gave the same query or same question, but I got different results.
It's certainly true. See, it's one of the paradoxes of, I suppose, the economy aspect of it, economics aspect of it. See, when you're using the free version of any of these models, right, you're basically traveling coach class, right? So the compute budget that you're being given is very tiny, right? And when you're using a paid version, you're paying the $200 a month. Right? And now they are serving you properly in the business class and welcoming you with champagne the moment you board. Right? There is a difference. So
but that shouldn't be like a slow rather than giving wrong answer.
What do you mean by slow?
Well,
This is okay. I'm a free version, so probably you are allocating less compute.
That is it. So whatever its preliminary answer is, it will serve it.
Oh, okay, it
won't do, because, and as you will learn, there's a lot of compute, but it will just take a very sparse slice of it and do only that much.
maybe it'll just give you the answer from its semantic cache. It won't even call the LLM.
Right.
It won't burn tokens for you.
Right. Because I had the free version, it just kept on asking me repeated questions based on the semantic cache. When I bought the plus version, it started giving me better answers.
Oh,
So this is it. You have to know. See, this is the economics of it. These are, believe it or not, 1 second. But when you give, see, for example, I gave it one query, and I think I must have set a record. It took 26 hours to answer. Right? Do you think you'll get that in the free version? Right? So anyway, Dhananjay, go ahead.
So as a for observation about the RAG really done well. As you know, I work for a large company, and even at our scale, what we're looking at is everybody is doing live RAG.
Absolutely.
Developers who think they can borrow 4 lines of code and write that basic RAG, they think their job is done. Okay. A lot of these developers don't even know some of the basics of doing a RAG system, like how to use the right encoder, what's a chunking strategy, and which are fundamental and critical to get that accuracy. And when they get some response out from
I think somebody's alarm is gone now. Okay, stop. All right. Yeah. No, you're right. Dhananjay, see, the point is that you're absolutely on the mark. I see it everywhere.
it's everywhere.
And
It's
all
just
in the
possible.
Fortune 500 companies I walk into.
Correct. And for these developers, all they do is they start tinkering with the LLM parameters about, oh, I should be maybe reducing the temperature or
Yes.
changing etc. etc. Without focusing on what is the actual accuracy. Why is your accuracy lacking?
Yes.
Because your context strategy was not correct. You didn't choose the right encoder, you didn't choose the right chunking strategy, etc.
Yes, absolutely. It goes far deeper. So yes, we are getting there. You're absolutely right. And this brings me to this. See, any one of these is a rabbit hole. You said chunking strategy, right? Yeah. I can produce 50 research papers on that. Yeah. Right? And see, there's something called a Dunning-Kruger effect, right? Which is the less you know, the more sure you are that you're the master of the topic. And there's a lot of that happening here in our field. Yeah. Anyway, so we'll talk about query routing. So now I'll give you a query. Let me think of a query and give it to you. And I promise you, I will move fast and get to the practical thing. Let me just say where author Middlemarch. I'm deliberately giving as ill-formed a query as possible. Spend childhood. How? Please. Can anyone of you decipher what I'm talking about? Warehouse author Middlemarch spending childhood. How plays influenza the leitmotif of stories? So now, what you have to think is there's a lot going on here, guys. Would you realize that most RAG systems at this moment would collapse? Try it out, something like this in your enterprise. So what is happening is, look at this query. First of all, it needs the grammatical correction, right? So what you would do is, you would look at Middlemarch here, author Middlemarch, right? What you can do is, you can do one parse of RAG just to, first you have to fix that. You can fix, let's try to fix it. Where? Which house? Did this is one correction we can make, right? Spend childhood. How did the place probably influence the, now this is another big word. And let's say that your machine doesn't know what that word means, right? As an example. So what can you do? You would do, so this is query normalization first. Then you say, okay, author Middlemarch. You pass it through the system, through your RAG pipeline. You will get some search results, right? You give to the LLM, the generator, the task not to answer the question, but to, to clarify the question. Are you understanding it? When you do that, in the retriever system will come out chunks, parts of the novels that this writer, anybody has read Middlemarch, by the way? Pre-tuition for anybody who has read Middlemarch for RAG course. No, nobody reads the classics anymore. Okay. Anyway, well, you lost your feet, 100% off. So anyway, Middlemarch is a classic of English literature. It's written by an author named George Eliot. which is the pen name of a person, Mary Evans. Mary Ann Evans. Right. And so she's my favorite author, that's why I picked her. And she used to write in the pseudonym of George Eliot because in that era, women were not taken seriously. One could argue even now some of it remains, but anyway, at that time it was much worse. So author Middlemarch, what would the search results come up with? It would come up with the fact that Middlemarch is a novel whose author is Middlemarch. So the LLM will catch on to that, the generator, because to the generator, what is the task you have given? To clarify the query. You didn't ask it to answer the query. It is using the search results to improve the query, right? So you remember one pass through the whole RAG system to just improve the query. At that moment, the machine now comes up with, let's say, a modified version, which house did the author of Middlemarch, George Eliot, Mary Evans, spent her childhood. You notice that now you know the gender, childhood, right? How did the place influence and now you don't know what leitmotif means. So you do a quick, the LLM can do this. It can do like, what's this? Recurring themes of a novel, right? Stories. She wrote novels. This query becomes, do you see that this becomes far more answerable? Isn't it? And so, and it is not done yet. What is the next thing it has to do? You realize that you need to answer this query first before you can even get to the second place. Right? So this is called a multi-hop query. And you need to query decompose into multi-hop. 1 second, I'll take your question. You need to first answer the first question. You need to have a understanding that you are even facing a multi-hop query. So at this moment, what should the LLM do? What should the system do? Ask this question. Now that we have an elaboration on this query, are we looking at a multi-hop query? Does it need query decomposition? Isn't it? If it needs query decomposition, let's start by answering the first query, accumulating the results, and using that to further query elaborate to answer the second query. Varsha, 1 second, go ahead.
My question is, as a human, when I look at it, I see all these problems, right? But as a machine.
That's what I'm telling you. A good RAG can do that. Try giving this. By the way, how many of you are on chat? If you're on the internet, I apologize for the bad networking. Try this query right now and see what the machine says. Try it out. I've never asked ChatGPT this question. I just cooked it up on the spot. But let's see what comes out. I'll give you a minute. Yeah, go ahead.
You mean like chain of what we have like answer it.
You can do that. So, Varsha, the question that you're bringing is, and since you bring the word chain of thought, are you deliberately inject? You don't do it with chain of thought, but a reasoning model will go into a chain of thought mode, right? And which is why, paradoxically, for the query elaboration part, transformation part, reasoning models do extraordinarily well. Now you see why, right? Because they need to go through a thinking process or COT. For this, but it's a very, very, very perceptive question. Any other question? Anybody had a question while you're trying this? Would anybody like to elaborate what's going on? What did ChatGPT say? Go ahead. You have a question. You raised your hand, sir. You raised your hand. Did you have a question? No, you, yes.
Oh, me?
Yes. Please go ahead with your question. Oh, you don't have, anybody has a question? Yeah, go
So,
ahead.
kind of piggybacking with Varsha's question. So this part is not part of the chain of thought. I mean, this is just
No,
cleaning
the
the
chain
query.
of thought you business. You see, the
That's-
old
that's-
chain of thought prompting was very good for Mary had 20 apples, she had 4, and this.
Right, right.
Yeah.
So
It
this
doesn't
is,
work in
this is
scenarios
going
like
step
this.
by step, but it's a cleaning of the query rather than
It is
The
the
actual
reasoning model coming up with a chain of thought,
Right.
not a chain of thought prompting. They are two different worlds. This is a reasoning model doing a chain of thought of its own, right, to come up with this,
It's exactly breaking it down.
breaking it down.
Yep.
Right? Are we? So, guys, do you realize now beginning to understand why RAG implementations suck? Right. So, anybody tried this on ChatGPT or probably? Yeah, go ahead. What?
So, what it is doing is it is latching a whole lot into the word influenza, and it identified the author correctly, Mary Evans, and her name and everything. But a whole lot of the following item is focused on influenza because it
Okay.
says as for influenza as a leitmotif, Eliot doesn't use influenza. as a
Okay, which is correct. It did answer it correctly, but okay, let me, maybe we took it a bit too abstract. Replace it with the word influence, but just misspell it. Remove the ZF from the end and repeat the query. And do this. So yeah, influencer is very specific and can derail it. That's too big a typo. So guys, anybody else got a response?
Yeah, again, this is interesting. So, yeah, with all 5 models.
Mhm.
So in that,
Speakers.
Gemini did not take it into 2, it came into 1 answer only, but Grok
What was the answer that Gemini gave?
Gemini said, so it assumed like you're asking just about the middle match.
Mhm.
So it says George Craig Eliot spent a childhood at every farm near some place in England. This rural setting specifically influenced her writing, particularly in her novel Middlemarch. And then it explained how it influenced Middlemarch.
Yeah. So Gemini didn't do a good job because we are asking the leitmotif of all her stories or novels.
Yeah.
Yes. What was the second model?
Second model was DeepSeek. So DeepSeek did take it into 2.
Mhm.
And in the first it told where the author stated, and then the second one it said was how influence part, yeah, influence the work.
Yeah, and then it answered that. And what is the answer that it gave?
The model of Sloamshire, I suppose I wrote the Sloamshire, this word.
Mhm.
The rural landscape of this place with its farm,
Oh.
estates, and it gave explain like the observation, the model of the importance of the place and community, access to library and education.
No. Because you didn't get the word leitmotif.
Yeah,
Yes.
that's why.
Yeah. So change it to leitmotif and see what happens. But yeah, now you realize that why DeepSeek really did have a huge impact. It's a reasoning model. You need a reasoning model to do this. Anybody else tried it?
You
Go
know,
ahead.
Gemini, I asked it, what was the, explain your chain of thought. Then it starts to say, oh, I kind of said Middlemarch is clearly Middlemarch. A leitmotif of stories, is interpretation of a library concept. And it said the user is likely asking what the motive or central theme.
Now you realize, right, why the whole traffic prefers going to ChatGPT instead. Anyways, yeah. So, there's a lot of scope for improvement. Let's just say it this way. We teach you to do better. Anybody else wants to share the answer?
You can.
Yeah.
So I just tried it on Copilot, so it's actually, but I think what it gave was the first when I wrote influenza, it couldn't get it.
Yeah, but when you said
But when I corrected it to just with the wrong spelling of influenza, then it said, you are diving into the roots of Middlemarch. And so then it explained about, let's explore the geography of George Eliot's early life and of his chapters
Okay.
spiritually.
It got onto the right track, yeah.
Yeah, it went on the right track, basically. Then it gives
Yeah.
real name, birthplace.
And you can see why, because of that, ChatGPT is heads and shoulders ahead of others.
Yeah.
Um, so this is again, guys, an illustration. So what we are talking about is multi-hop query. Do you see the value of detecting that? And by now, I hope you realize what I'm trying to teach you here, that query transformation is of paramount importance. 1 second, Gosha. You realize who is doing all of this back and forth. You need an agent, an LLM, which is iterating over partial results and thinking what's happening, isn't it?
This is not one shot.
This is not one shot. It is iteratively working. And then the other aspect is, and I'll move a little bit faster. See, when you have a query, you need an agent to also determine this question, is it best answered by a database query, best with a web search, best going to this search index, right? Best diving into your GitHub repo, right? As a MCP tool, Model Context Protocol tool, or so on and so forth. Something needs to continually be deciding how exactly to navigate the user query, because now you are in execution mode. So that is the part of query routing. Who should you route the query to? Should you route it to a text to SQL engine that will extract the information from the database? Should you route it to the web search? Should you route it to your vector search index, right? Should you write it to this or that and different search indices? That is query routing. It produces the results. All of these retriever systems will produce results. You need to merge the results now, right? That merging is re-ranking. There is a deep theory and architecture for doing re-ranking properly. I won't go into that because we can spend the whole night talking about re-ranking. We can spend the whole night talking about how to do the good embeddings. Should you convert text into one vector? Should you convert it into many vectors? Should you convert it into a low dimensional vector? Should you convert it into a high dimensional vector and a low dimensional vector? Right? So there are all of these concepts of Matryoshka embeddings and so forth comes in, right? What is the place of keyword search, the traditional keyword search, display and so forth, right? All of those things come together in the retriever system and the re-ranker that goes in there. The vector databases, the keyword database, the relational database, everything that is in there, APIs and so forth, right, is making up the retriever system, for sure.
So why am I trying to do query decomposition in the retriever? Why can't I just send?
No, before the retriever, it's before the retriever.
But shouldn't the LLM do the decomposition?
No, LLM is doing it.
They would love it.
There is an agent sitting there, LLM. So what I'm trying to tell you is there are different LLMs, there are different models. One, the reasoning model is sitting, pondering over the query and thinking, what should I do with the query? Fixing the query, decomposing it, and then shooting one by one, deciding where to shoot it to get pieces of the answer, right? And doing it. And in other words, I'm breaking you out of the mold in which you think query goes into the retriever, top results go into the generator, LLM, and out is the answer.
And so can I rely on an LLM to do the query decomposition?
No, you do the query decomposition, but see, not everything can be done, right? An LLM iteratively has to work through each of these steps. There will be LLMs involved, but what size LLM? Just query normalization. Do you really want to bring in GPT-5? No. You need a tiny LLM. A query contextualization, if you're in the agentic system, you need a MCP tool. Because who is this user? What is the case incident that we are talking about is relevant. Query rewrite, a tiny LLM can do. Query decomposition, no, not tiny LLM. A bigger reasoning LLM should do. You're understanding it, right? So you build many models into the pipeline, and way before it, even more models came. Remember, the relevance detector came, the gibberish detection came, semantic cache came. So a good RAG pipeline is an ensemble of many really fine-tuned models, each model having a place under the sun in helping answer the user's query, right? Then the query, let's say that you re-rank it and you send it into the generator, the final generator that has to now The generator now becomes the editor. It has to create a draft of the answer. It creates a draft in a scratchpad. Do you trust the draft? No. What if it contains toxic language? What if it has adverse impact against one of the protected classes? What if the answer is biased against, let's say, blacks or women, or pick one, right? People with disability. What if it recommends that people with disability certainly don't deserve any more leaves? Right? What would you do? So you need to, now the draft needs review. If nothing else, for adverse impact, for toxicity, etc. But more than that, most importantly, you need to check whether the answer actually answered the question. You need to also fully answer the question. You need to also verify that every assertion in the answer is coming from the sources. It's not answering it from its parametric memory. And what is worse than answering from a parametric memory? Hallucinating. Right? How do you do that? There are measures. So that's what some of the details we teach here. So what really happens, for example, is one of the telltale signs, not the only sure shot proof of it, but one of the things is when the LLM is answering, if you look at the probability distribution over the tokens, you will notice that entropy shoots up, its confidence goes down. When the confidence of the token generation goes down, you know that there's a high likelihood that the system is hallucinating. Yeah. But even if it is not hallucinating, it's a time to stop it and go back. And whatever answer it has produced, go back to your retriever system, find more information there, bring it back, and try to re-answer the question with more information. So you need to keep an eye at the internal, because LLMs don't just produce tokens, they produce a probability, and you can keep track of the entropy. You can keep track of the confidence with which it is coming out with those answers. If it is losing confidence, you need to drag in more data from the retriever system to better answer the question. So it answers the question, you get a draft, you need to take every assertion and source it. You know, when you go try searching in Perplexity, one of the qualities which I feel is absolutely admirable about Perplexity is, have you noticed that every time it says something, it gives you a reference right there itself to one of the search results. Right? I call that grounding or citation. You need to ground every assertion of your answer in one of the search results. Right? Finally, see, a good answer, and we talked about it last time when I demoed it to you, a good answer should contain an answer. It should contain the citations, the sources. It should also contain, because people don't like all the reading, it should contain a condensate, key highlights of the sources, you know, the source documents that you found, right? And finally, the fourth leg of a good answer is it should end with leading questions. Do you notice that ChatGPT, Perplexity, they all end with leading questions, right? So I'll stop there, guys, with the theory. 1 second. I'll stop there with the theory, guys. Are you getting a sense what RAG really entails and why I started by saying, and I haven't even scratched the surface, by the way, right? The sheer amount of work that has gone, graph RAG, graph neural networks, agentic systems, iterative, the evaluation metrics, and so on and so forth. It's a big world, right? And to do it right is the most fun thing you can do, the most satisfying thing you can do. But for that, you have to know what is RAG, right? Do not be fooled into the belief that just because you picked this or that Python library, right? Oh, look at that, I can do RAG. Because results come early. One of the paradoxes in AI is it takes 20 minutes to get early results and to go impress your leadership. It takes an eternity to fix it and make it work after that. That is the paradox. MIT just came out with a study saying 95% of AI projects fail. Are you surprised? Right? Because they always underestimate the size of the project.
Everybody's in POC mode, eager to please.
Exactly. Very, very few things go from POC to production in our field. It's a very disappointing statistics. Go ahead.
Yeah. So alternatively, when I fed in a query of like, give me the Tirukural 300. Like Tirukural is kind of, it consists of 3,444 individual versions, right? when I just give a number, like give me the 304 Tirukural, ChatGPT cooked up a Tirukural and gave it to me. It was never found in that Tirukural book, something totally new, and it even gave me a detailed explanation of what that Tirukural is.
That's hallucination.
I reiterated the query by saying, can you give me Tirukural 304 written by Tiruvalvar? It gave me the same and it gave me a detailed explanation of that Tirukural which is not
No,
found in
thank
that
you for
book.
pointing that out. So I have two comments on that. See, if you look at the hallucination aspect of it and the grounding, foundational aspect, I do feel that Perplexity is the leading horse in that. They do it very well. Try it out in Perplexity. You will probably see that it does. Actually, why don't you try it out right now and tell us all what you want.
Perplexity does a lot of advanced things.
Yeah.
You know, Perplexity, for example, does fact checking. It does bias, left-right bias.
That is it. That is the groundedness. Yeah. We call it
Perplexity
grounding.
is to me state of the art.
Yeah, it's very good. The second aspect is that you might have been traveling coach class. Right? You need to use the Pro model. Right? I think ChatGPT 5 Pro model is quite good actually. I would be surprised if it still hallucinates on such a simple question. Somebody else had a question or hand raised, please.
Why doesn't the model say or admit that I don't know?
Because it cannot. It doesn't know that it doesn't know. I mean, think about it this way. Have you ever met an engineer who says, I don't know?
I love that. I'll take that up.
And ChatGPT is the brainchild of engineers.
Yeah, I mean,
Stealing that data.
that's much better than saying, continuing to say something completely wrong off the rails.
No, there is a
And
fact
if it is intelligence, then it should detect.
that it doesn't know. No, it does actually. The point is that, like I told you, there are entropy and confidence measures by which you can tell that the machine at this moment is losing confidence in its answer. But these machines have been trained to always answer the question. Guys, we'll take a small break in a moment. So always answer the question it does. But here's a fact, guys. Recently, GPT-5 Pro thought about a question for many hours and finally came with the answer. I really don't know. And in our field in AI, that was one of the most spectacular achievements of research, that GPT-5 Pro. For the first time, a model came out and said, I don't know. And it knew it had that amount of intelligence to know that it doesn't know, right? After all the research. So progress is happening very fast now. And in fact, Elon Musk commented on it, even though it is a competitor product, Elon has his own growth. He remarked on it that this is actually an outstanding achievement that the LLM came to the statement unforeseen before, saying, I don't know.
I remember a question I asked in DeepSeek. I think it's DeepSeek. He came up saying that timeout or something. When I rephrased the question, he gave me the answer.
Yeah.
Probably that's the way saying I don't know. Instead of saying I don't know, it says timeout and
Yeah.
it's busy. And then like when I rephrased the question, he gave me the answer.
So, how do we do authorization in this, especially in an enterprise?
Oh, that again is another kettle of fish. The way to, how do you do authorization? By coming to my course. Yeah. Okay, guys. Okay, let's take a 10 minutes break and then we'll get into the coding, guys. Get your laptops ready. Have we all downloaded the code now? Okay, guys, let's pause the recording. Welcome back, everyone. I'd like you are you guys all able to see my screen?
Yes.
We are, but I have no idea which screen I'm sharing. Okay, good, much better. And let me maximize this. Oh, this is better. And so guys, a little bit about this project and how to run it. There is a tool called UV. How many of us are familiar with UV? A couple of you. How many of you? Most of you are not. Okay, so it will be a long night. So it's a very easy tool actually to do it. So we'll have to start a little bit back. Let me start with UV then.
This is
See,
getting
UV is a tool. That, how many of you are familiar with PIP? You are familiar with PIP, isn't it? So it's like PIP. Except that it's more modern and the whole open source community and all the corporations are moving to UV, right? So what we will do is we will start with giving you a small intro. You'll enjoy that. If you are, how many of you have done PIP, installed something and something else broke? Right? One library, dependency conflicts, etc. So you live in the, if you live in the world of PIP, then PIPSIO takes you through some very complicated dependency problems. UV is a new tool. Its singular quality is A, it's blazing fast. B, it does everything possible to prevent a dependency problem, dependency conflict. It won't let you install something into your project if it cannot find a version of the software that is compatible with the rest of the things that you have installed. Isn't that a wonderful thing, right? And also compared to PIP, it's literally 1,000 times faster. When you install anything, it just blazes through. So I'll take you through the install of this, since you guys don't know that. So do one thing, just Google UV install. It's a very quick install. You see the first link? Astral doc installation UV. Just pick your operating system and execute one single line of command. Do you see this command, guys? Whatever is your operating system, just execute that. I'll give you guys 2 minutes to do it. Just do that because the project that you downloaded won't run without it. And I'll give you, while it's a bit of a digression, I'll give you a short introduction to UV. If you're on a page that looks like this, you're in the right place. It's a GitHub project that has 66,000 stars. So you can imagine that it's not a, it's one of the flagship open source projects. And it is replacing PIP very fast now. How many of us succeeded in installing? You did, all. How many of you have not succeeded yet? If you have installed UV, then you can go to the command line tool. I will just give you a very quick tutorial on UV, just so that you become familiar with how to navigate this RAG to Riches project that you have downloaded. See, can I move ahead or somebody is still doing it? Okay, I'll wait a couple of minutes. By the way, a show of hands, how many guys did I brainwash into doing RAG properly? I'm kidding. It's fun, isn't it? Building a good architecture.
Yeah, I didn't realize RAG is such a beast.
And now you know why most RAGs don't work. I mean, they sort of work, but they never work to perfection. So while people are installing it, I'll tell you something. 2023, RAG comes out. I like to print research papers and study it. So I took a small binder, 1.5-inch standard binder, and started putting research papers of RAG in 2023 early. It filled up fast. I said, okay, one more binder. Filled up fast. I said, okay, it's growing. Let me take a bigger binder, 3-inch binder now, next time, right? So I got a fat binder and started putting research papers as I was reading them into it. After a little while, the whole shelf was filled with just RAG. So then I said, okay, I need to stop. So now I have this high a pile of papers over the last 2 years that I've gone through on that. And this is true of everybody who has been deeply into it, because at the end of the day, you realize that recommender systems, Rexus, which was the recommender systems, which is the workhorse of the industry, and RAG are essentially the same thing. You realize that that all of these big things like ChatGPT, Perplexity, they are all RAG. And you realize is that the poster child of generative AI is multimodal agentic RAG. It is the thing. So you cannot have just one binder on RAG. You need a library on RAG, library of papers on RAG. There's so much work is happening in this space. Really.
Have you built a RAG system to try and search it yet?
Actually, I did. Thank you for asking that. We have actually. It's one of the projects actually. When you do the RAG course, it's an optional project that you do. You have to create a RAG implementation on all the RAG papers and articles that you can find, right, to help you answer the question. It's fun actually to do these projects. So people do interesting projects. One of them, somebody mentioned Thirukkural. The person here, Sushinda Rajan, he has created what I consider the world's best AI interface to the Thirukkural, which is a Tamil sort of a cultural asset, right? Thirukkural. It's and actually, it is the leading asset, the web portal for the Thirukkurals. You can ask questions in Tamil, you can ask questions in English, you can ask questions in Chinese. It will still answer you in the language that you asked by dipping into the Thirukkural, right? And if you Google for a Thirukkural's site to solve your problems, most likely you'll hit his website because it is the leading site now, and he did it literally as part of this course. Yeah. All right, guys, can I assume that we are there now? Right. So a very basic introduction to UV. What it helps you do is, let us say that I will. Oh. So suppose you want to create a project. We want to create a project, right? How would we create a project? You would say UV init. You can give some project name. I'll say that because so would somebody like to suggest a project name? Which one? Grasshopper. Okay. Grasshopper. Now, in AI, it's one of the lessons you learn in AI. Don't use the latest Python. AI libraries haven't caught up to it. So what is a better Python version to use? As of this moment, the latest supported version is only 3.12. Most of the prestigious libraries, PyTorch, on which everything is based, is still at this. What does it say? We just created a project called Grasshopper. Right? We can go to Grasshopper, and now we are inside the project. Now, what UV does, it takes a very interesting approach. Guys, do you remember that in Python we have virtual environments to contain your project? Trouble that happens is that you forget which virtual environment you are in, right? You're in one project and you start, unfortunately, adding libraries to another project's virtual environment, right? So UV takes a very disciplined approach. It says that every project must own its own virtual environment. Are we together? So if I do, you notice that as of this moment, there is nothing here. There is just an empty project, Py project, which just says version blah, add your description, very minimal. Python is this. You don't even have a virtual environment. Now here's the beauty of UV. You need not even have installed that Python. Let's say you say I depend on Python 3.x, but 3.x is not on your machine. No problem. It shouldn't be on your machine. You just need UV, And if you do UV sync, let me just say upgrade. This is a command that is very useful, UV sync upgrade. What it does is, it immediately creates a virtual environment, and any library that you depend on, it will update that library. Are we together? So now what has happened? If I do ls minus l, you will notice ls minus a. Do you notice that there is a, do you notice this particular line, guys, .env? A virtual environment has been created that belongs to this project itself. You want to add any libraries? Let's say that I want to add, for the sake of argument, I want to add a library called transformers. Right? So look at this. Oh, by the way, have you ever tried pip install on transformers and seen how long it takes? And did you see how fast it happened here? Lightning fast, isn't it? That's the beauty of UV. It just goes blazing. Right? It does. It's written in Rust, by the way, very fast language, and it does it. So now we have added a dependency. You can add more dependencies. Suppose I say UV add. I want to do some visualizations. Matplotlib, right? Maybe I want to add pandas. Maybe I want to add PyTorch. Right? Oh, sorry, Torch, not PyTorch. Torch. Do you notice that everything gets installed almost immediately? So this is UV. If I want to build this project, what do I do? UV build. Look at it. In the world of Python, the distributions are called wheel files. Are we familiar with wheel files? It has, you see that you have a wheel file now, right? You have a wheel file. You want to run it, UV run. Let's just say main.py. Hello from Grasshopper, right? Where did it come from? Main, obviously main. If we look into main, you'll notice that it is here. So you don't have to worry about, oh, which Python am I invoking, etc. It will do that for you, right? Now, suppose you want to publish it and you have a PyPy. Suppose I say UV publish. Well, at this moment, it forbade me, thankfully. Otherwise, in PyPy, I would have added it. Actually, I need to log in as the right user. But yes, this command, assuming that your keys are properly set up, will help you publish your wheel file to PyPy. Why is that relevant? Because other people can do UV install or pip install and install your library. Does it make sense, guys? Right? So this is UV. Now, the project that you got, that you downloaded, is a rag to riches. Isn't it, guys? It should be looking something like this. And now, those of you who like VS Code can open it in VS Code. Those of you who like to use Cursor can open it in Cursor. It really doesn't matter. If you like PyCharm, use PyCharm. You want to use, almost all of them respect UV. Right? The good thing with UV is that now that all the IDs support it fully, the moment you open the directory, VS Code, Cursor, PyCharm, they will all immediately become aware of your project structure. They will read your PyProject TOML and they'll become aware of your code. Does that make sense? Now, in every Python project, there is usually there is a environment variables where you keep some of your secrets. Not the safest way to do that, right? But still, the convention in the world is that you have a file called .env. Right? Do you see that I have a .env file in which you keep your secrets? What would be one secret worth keeping in the case of RAG? API keys, right? API keys. So in this case, if you must be when you downloaded the project, you must be seeing that there is a file called sample.env. I would suggest copy sample.env to .env. Right? In other words, CP let me do this here. CP sample.env to .env. I won't do it because it will overwrite my version. Right? Does that make sense, guys? Right? A copy it over. Once you do that, more or less your project is ready to go. I'll show you what is in the sample.env. Let me open it. Here is what the sample.env contains. Oh, by the way, ignore, can you please, I made the mistake. This copyright notice has to be taken away. Huh? Guys, feel free to use this code. Right? This is a boilerplate code from our team, but you can ignore this. Feel free to use this code for whatever purpose you want. It just contains what is the root directory, project, etc., etc. And here is your OpenAI key for this project. That's all you need. After that, if you open this project, and by the way, let me be explicit. This copyright notice, I forgot to take it off. Assume that you own this code. Yeah? Right? You can assume that you own this code completely. So you have full license to use it, whichever way you want to use it. And now we will go and we'll go back to our RAG to riches. At that particular moment, if you open your code, I happen to open it in Cursor, by the way, guys, which is the same as VS Code. It should look more or less identical. If you're using PyCharm, also it will look rather similar with minor differences. I want to show you this code. When you are in this code, guys, open it in Cursor. The first thing you should do is just go to the terminal. If you have any doubt, you can just do source.env. So that your OpenAI key is now detected, right? This is just a precaution. Actually, you don't need to do that because Cursor and all of these things, the moment they say, the convention in Python is .env file should always get loaded, right? Always get source. The other thing is, if you really are in doubt, remember the virtual environment that you created? Most of the time you have to enter the virtual environment, right? But the good thing with Cursor and all of these new IDs is, because they are aware of the UV structure, they automatically put you in that virtual environment, right? But just in case you're not, you can still do that. You can do .vn bin. You see that virtual environment bin activate. You know, the same thing that you do with pip, virtual environment. You can still go ahead and as a safety, activate that environment.
So as a point for when she does source bin activity, it is saying that source not a directory.
Okay, so I'll come and help you afterwards. Huh? Let me come and help you. Did you do UV sync after in that direct? By the way, I must also say, in your project, guys, when you enter this thing, it is always a good idea to do UV sync upgrade. So this is the first thing you should do in your project. Do you notice that it went and updated a whole lot of projects, installed and certificates, etc., etc. Right? In my case also. So go and do UV sync upgrade. Are we able to do this, guys? Yeah, we are able to do this. Right? At that moment, your project is fully set up. The code, and those of you who are struggling, I'll come and help you. Samantha, are some of our TAs available?
Yes, let me call them to join.
So they can join after 15-20 minutes and help the people here. All right, guys. So with that thing there, now you can play with this, guys. You see the example, the examples under SRC. guys, you will see rag to riches. Let me explain this code to you. Once again, the basic rag, remember, is the way this basic rag code is mostly taken from, it's an adaptation from a basic code from the Llama Index website. What is the issue with this code? Remember, yesterday we walked over this, right? You give it a directory of files, documents, and you say, I'm creating a rag on this document, right? So this is this line saying, line 22. Please pay attention to line 22, guys. The rest of it is just imports. Line 22 says, simple directory reader. What could it possibly be doing? Reading all the files in that directory and loading it into your vector index. Then you get those documents in line 23, you end up with a vector index. In other words, a way, something that you can search through. And now you turn it into a query engine, means you can search into that. And then you ask it a question. Then you ask this question, by the way, where is my LLM? Where is the generator? This is the retriever, isn't it? It's a search index. Where's the generator? The answer to that is, it's the way Llama Index did it is, it baked it into the as query engine, right? It will take the search results and feed it into the LLM, into the generator. Where is the LLM? Well, it's the OpenAI at this moment, right? So now you get the response. You remember that the document was actually about, if you go and look at the document starter, you realize that this is about Greek civilization, Greek world. But we asked a question about Greek world, it gets the answer from the document. But if we ask a question about the Indian civilization, nevertheless it answers. Do we want that answer or do we not want that answer? It depends on your context, right? But in most enterprise environments, you would rather not have that answer. You would be careful. You want the answer to only come from your documents. Isn't it, guys? So that's one of the limitations of a simple RAG. It gets you going. Other problems are, every time you ask a question, you have to index all the documents in this code. More significant problems is, remember, the whole architecture that we talked about has been skipped. Right? Nevertheless, it is a good way to get your feet wet. Right? So, guys, go play with this. Put something in there. Play with this, and then I will show. I give an example of a RAG, which is a little bit more. A little bit more realistic. So let's look at the data model called this file called datamodels.py. It's under corpus, rag to riches corpus. So it has something called animal quote. What is an animal quote made up of? It is basically a text, somebody's quotation. Let's say Einstein said this about animals. Who is the author? Einstein. What is the category? Maybe one or two categories associated. So what do? You have a text and some metadata, author, category, metadata associated with the text. You'll put that into the search index. What's an example of the document? We saw in the docs, corpus, no, not in the docs, sorry, data. You see the animal corpus, guys? Look at this. Let's look at one quote. Dogs never bite, just humans. Author is Marilyn Monroe. Insightful observations. Well, take it for what it is. So it's just made up of quotes. So you notice that every text has an author and a category. Make sense, guys? Right. And so we are loading it into the data model. Data model quote. Do the three fields of it make sense now? Text, author, category. They do hopefully make sense. And then animal wisdom is nothing but collection of those quotes. It's a list of those quotes. Right? Quote, it's a list of animal quotes, along with which file you read it from. Makes sense? Which JSON file you read it from. That's all. And then some validators. The rest of it is housekeeping. Get categories, some helper methods. Right? How many of you are familiar with Pydantic? Oh, okay. If you're not familiar with Pydantic, as the author of Pydantic says, Pydantic is all you need. Right? So he has a talk with that name. And then a few years later, he gave another talk whose title was famously, Pydantic is still all you need. Right? So Pydantic, by the way, guys, in Python is one of the most influential libraries. What is Java Beans in Java? Entity Beans in Java? Right? What is struct in C is a Pydantic data model in Python. Is the right way of creating data models. Are we together, guys? If you're not familiar with Pydantic, do become familiar with Pydantic. I would strongly advise it. Right. But anyway, the rest of it is validation. It just makes it loading data, doing basic validations, etc. Very, very easy. And it's lightning fast. Pydantic is mostly implemented under the covers in Rust. Right? And as you know, Rust is a very fast language. So now let's look at the animal class. We'll go over the animal class carefully. By the way, guys, do you want me to go through this, or is it too involved at this moment? You would rather go home? Let's go through 10-15 minutes. Animals class is the main RAG class. Think of it as RAG. So what are the steps of the RAG? What are the key features? You will load the codes from the JSON file along with automatic validation. Means because of the Pydantic, it will make sure that you have, because is a quote if the text itself is missing? It wouldn't be, right? So a semantic search using state-of-the-art embeddings. Well, state-of-the-art is a bit of a stretch. We are using a very simple embedder, but still, filtering by author, category, or similarity, AI-powered question answering with GPT models, beautifully formatted output with rich library, complete RAG, etc. These are some of the features, and take it with a pinch of salt. But we do a typical workflow, initialize with a vector database. Makes sense? First, you need a vector database, empty vector database, isn't it? Then you need to read the JSON file of all the codes and do what? Each text, make it into a vector, put it into the vector database. We learned about that last time. We do that. Next, what do? Well, let the vector database index all the codes, number 3. Finally, we are ready. So we can now search. You search for relevant codes, search results come out, and then you give the codes over to the LLM and ask the question. Isn't it? That's a guide. So, and it even gives you examples of how to use this. Right? Attributes, embedding, construction. So this is it. Let's look into forget the requires, etc., which is my very strict way of putting, but look at the init. What it says.
Can we run the code without the OpenAPI key?
No.
Yeah, that's right.
No, what you have to do is you can run it with a local LLM. So for example, if you have Llama in-house, see, if you have Ollama, you have
yeah, so I think all of these folks, I don't think they have
yes. So here's the thing, guys. If you are technically savvy and you're running LLMs locally using LM Studio or Ollama or VLLM, then of course you know what to do. You don't need an OpenAI key. On the other hand, if you don't, my suggestion would be that going with OpenAI, which by the way is an anti-practice in my opinion, you shouldn't do RAG with such a big model. It defeats the whole purpose. Plus there's data exfiltration. You're sending confidential data to the web. Right? But nevertheless, just to get started and do toy examples, starting with an OpenAI is a good idea. Just to start, right? Not to go to production with it. Start, because all you need to do is go to OpenAI and get yourself an OpenAI key. Ask ChatGPT how to create an OpenAI key, develop an account, and get an OpenAI key. It's very simple. It will take you a couple of minutes. Are we together, guys? The only reason I can't show you the steps is because then you'll all see my OpenAI key and I'll go bankrupt. So that thing, I leave it to you to ask ChatGPT to educate you on how to get you to create an OpenAI key. Okay? So that is that. So guys, this thing needs an embedder to create embedding vector database, embedder to convert text into, what does an embedder do? Convert text into a vectors, right? That is it. Collection name, well, you need some name to give to it. So you need an embedder, collection name. You load all of the codes, semantic search. You do that. And there is one method. Ultimately, the one method that really matters is the outline. The only method at this moment that you care about is the RAG method. What does the RAG method do? Takes the user query, everything else is given. How many results to get? 5 results. Author is optional. Like you can say, answer this question only using this particular author, etc. You could do that. So all of those things, it is best explained by examples. And let me go and show you examples. Simple RAG usage. So we will walk through the RAG, and this code, guys, all you should do is just run this class. Simple RAG usage, and keep changing the example here. So guys, I've limited the implementation to basically 3 files. If you spend time studying it, did you get a sense of these files now? The model is animal quote, animal wisdom. Animals is the main RAG class, right? What does it do? It loads all the codes from JSON, puts it into a vector database, and makes it gets query results and passes it through the LLM, right? How do we use it? First, you go and get the vector database, you get a text embedder, you give it to the animals class, now it's ready. It will go and read all the documents. Now you have a query, you have a different query today. What makes golden retrievers so special? How many of you agree that they are special? A few. Okay. All right. So we have what? So and then, do you see, guys? I've look at line 44. Animals.rag query 3 limit 3 search results. Response type structured. Why did I give response type structured? Oh boy. What could be the reason? Because I want the response to be a data structure which contains answer, highlights, query search results, isn't it? And leading questions. It's a composite object, isn't it? Guys, if there is one simple takeaway for you when you do RAG, never have RAG just give a plain simple answer. Why would you trust that? How do you know it hasn't hallucinated? Doesn't it? Doesn't your user deserve an explanation or some reference to validate whether the answer is correct or hallucinated? So always return. So where is that data structure? Oh goodness, did we cover that? Let's go and look at it. Oh, animal response. It is in the response. It's in the animals class. Animals, animal wisdom response. Look at the response. It will contain the answer which everybody thinks of as string, right? But more than that, what does it contain? Key highlights, then recommended quotes, like basically where did you get it, and follow-up questions. Why recommended quotes rather than search results? Because some of the search results may be irrelevant. So you make the LLM do extra work. Only recommend those search results which were relevant to answering this question, isn't it? So it's an extra thing that you do. So this is how I would suggest that you do it. Ask LLM is simple. You just do that. So guys, this is it. This is one question. So you ask this question, you go and look at the response and you print out the response. Is this code looking easy to understand, guys? To get started, start with this, play with this, and then work backwards. All you have to do is read the animals class, animals.py. Are we together? Method by method, and you'll have a fairly good understanding of RAG to get started, decently started. Right? I remember when participant came and said, it's already ahead of what we were doing. So it just shows how people move ahead. Right? So this is it. So let's find out what's special about golden retrievers. And we'll end with that.
Yeah, but it's a stupid question, but from what it sounds like, the RAG is prescriptive. Is that true? I mean, so that you do, query rewrites, you do, gibberish.
It's a pipeline. See, all architecture is prescriptive by definition, and RAG is AI systems architecture. Right? So generally, what happens is you distill all the research papers that come out and all the experience into one architecture that you build.
Oh.
And therefore it is by nature prescriptive.
And it could vary, I guess, depending on who knows what.
Exactly. And how and what the context is, what the domain is, what problem you're solving, and so forth. That is why, right, RAG should never be, if you go to any cloud provider, they will all tell you, just point us to your document and we'll give you RAG free, right? We have simplified it for you. Every single cloud provider will tell you. Right? Should you use those systems to get started? Should you end with that? What is the opportunity cost? Those are not good systems because they're general purpose baseline systems, isn't it? They will do some, the marketing literature will tell you, oh, they do keyword search and vector search, and then they do this, and they have guardrails, and they'll pass it through LLM. Yes, nevertheless, it's not specific to your domain. Right? And in fact, I happen to know because I play with all of them. They don't have the same maturity level as what, for example, I took you through. Why? Because they are catering to like there was once a book. What is it? Gold is at the bottom of the pyramid or something like that. The famous economics book. Basically, the widest market is what? Total addressable market. If you look at it, there's a big total addressable market of people who just need good enough rank. And the cloud providers are giving you that. But if you really want, if your business, it is mission critical for your business, for heaven's sake, don't rely on that. Build it. That's a way to look at it. You have to build it properly. And you learn it along the way. What happens is you do something, it doesn't work. People point out errors, and then you go back and start fixing it, adding more to it. So, oh, look at this. Let's see what it says. Golden retrievers are often celebrated for their loving itself. Alfred Blah. Yeah. So you notice that this answer is very grounded from the quotes. Right? That is it. Blah. These qualities are emblematic of the golden retriever, etc., etc. So it's an answer. Key insights: golden retrievers are symbols of love and loyalty, the soulful connection between humans. So do you realize that everything is giving like some of them at least is giving you references, recommended quotes. Recommended quotes is which of the search results were relevant, and it gives you the 2 quotes, and it gives you the follow-up question: how do golden retrievers compare? Blah blah blah. Right. So guys, is this the way, for example, ChatGPT or Perplexity answers your question? Right. Let's go and ask the same question from Perplexity. What makes golden retrievers so special? Should we try that as a concluding exercise? Let's try our luck. What just happened? Okay, look at the response, guys. How many of you think, what do you notice? There is an answer. Do you see that the sources are mentioned right at the top? Right? Images, sources, steps. It even shows you how it went about doing it. Right? And do you notice the one message? RAG is not a straightforward single pass through the system. And therefore, guys, now do you realize why? And do you see at the end of it, leading questions? Right? So treat these top tier RAG implementations as your, in painting, you learn painting by copying the masters. I used to be a painter long ago. So my teacher, the professor, he asked me to pick a master. I picked one, I picked Rembrandt. I said, okay. He asked me, Ray, who do you like most for this? I said, oh yeah, I really love Rembrandt. I didn't know I was falling into a trap. He says, okay, which one? And I picked up one, and it was a difficult one. He says, okay, now for the next 3 months, you're going to paint this. Right? So you learn painting by painting the great masters and achieving that same thing. So if I may say so, if RAG is a painting, paint perplexity, right? Or ChatGPT, try to achieve the same bar. And as you iteratively try to do it, these techniques will come to you. So, and with that, I will end. So, well, that's that. With that, I'll conclude today's session. I wish you all the very best. And I hope to see some of you. If it has piqued your interest, I hope to see some of you in the RAG course.